What's up everyone? For today's video, we will learn about sequences and series. Our primary goal for this video is for us to understand how we can recognize and identify patterns of numerals and even other entities and relate them to one another. With that, let's define series and sequences. What are sequences? Well, relevant to our previous videos, a sequence can be classified as a function whose domain is the set of positive integers or the set 1, 2, 3, ellipsis n, so on and so forth. But how about series? To simply put, series is just the sum of a specific sequence. Instead of being separated by commas, operations of addition are placed in between elements. Hence, series can be represented through the notation a sub n is equal to a sub 1 plus a sub 2 plus a sub 3 plus ellipsis plus a sub n. Let's try to get the series and sequences related to these two expressions. First, suppose the expression is 3n plus 1. How can we write the series and sequence of its elements? As we said earlier, the domain of any sequence starts from 1. Hence, we just have to substitute the first 5 positive integers to the variable n and divide their positions using commas and operations for the sequence and series respectively. By substituting 1, we'll have 3 times 1 plus 1 is equal to 4. For 2, we'll have 3 times 2 plus 1 is equal to 7. For 3, we'll have 3 times 3 plus 1 is equal to 10. For 4, we'll have 3 times 4 plus 1 is equal to 13. And lastly for 5, we'll have 3 times 5 plus 1 is equal to 16. Thus, our sequence for that expression is 4, 7, 10, 13, 16, ellipsis, n. Take note that the ellipsis represents the numbers in between the last specified number, which is 16 in our case, and the n, or often the value we want to find. So, how about its series? We just have to replace the commas with addition signs and we'd get 4 plus 7 plus 10 plus 13 plus 16 plus ellipsis plus n. But when will we try to simplify those numerals? The answer to that question is when the problem asks us to. For instance, aside from finding the series and sequence, the problem supposedly requires us to find s sub 2. Then we'll just have to add the first two terms. So, 4 plus 7 is equal to 11, and s sub 2 is equal to 11. If it's s sub 5, then we just have to add the first 5, 4 plus 5n plus 10 plus 13 plus 16, and we'll have s sub 5 is equal to 50. Easy, right? Also, did you know that this expression 3n plus 1, together with other sequential conditions, is considered to be one of the remaining unsolved problems of mathematics? This expression is commonly regarded as the Collat's conjecture or the 3n plus 1 problem, which a renowned modern mathematician named Paul Erdos regarded mathematics may not be ready for such problem. Try to research about it and understand the horrors it radiates to present-day mathematics. Going back to our main topic, let us now try to solve the series and sequence of the expression 3n squared plus 3n plus 1. Like what we've done earlier, we just have to substitute 1, 2, and 3 to n, and we'll get 6, 17, and 34 respectively. From there, we can arrange the sequence to be 6, 17, 34, ellipsis n. Why is it that I only conclude until the third term? It is because generally, 3 elements should precede an ellipsis for a pattern to come. Meanwhile, its series will be 6 plus 17 plus 34 plus ellipsis plus n. As simple as that. Now, it's your turn. Try to find the respective series and sequences of the following expressions listed. See you next time as Archimedes awaits you. Subscribe to our channel and click the notification bell to be updated for our next videos.